This video is over topic 8-4 for systems of inequalities. Remember that we must graph both of these lines. Before we can graph, we have to solve. So the first one, y, is already by itself, but for the second one, we have to move x. We move x by doing the opposite operation, so subtracting x, and bringing the 4 down. From there, we still don't have y completely by itself, so we have to divide everything by -1. And get y is less than or equal to x minus 4. It is less than because we divided by a -1, so our sign flips. So to graph and shade this line, we go down to -4. The -4 is where we start. The x tells us our slope is up 1, right 1, because there's an invisible ninja 1, so up 1, right 1, up 1, right 1, up 1, right 1. Because there's a line under the inequality, this line will be solid. And y is less than or equal to -4. Less than -4 would be lower than -4, so we shade underneath or lower than the line. Remember, if you get confused, always go back to that y-intercept and say what is less than -4. Less than would be lower, so I'm going to shade underneath that full line. This one we didn't have to solve, we just need to graph it. So we start down at -9. My slope is up 3, right 2. This line will be dashed because there is no line under the inequality. And y is everything greater than -9. Numbers that are bigger than -9 would include a +10 up here. So I could start at +10 and shade all the way down to my line. And remember, my solution set is the point where they cross. So this triangle up in here. Where the red and the blue cross all the way up into those lines. So that would be my solution set in here. And remember that if you want to, you could highlight it, you can outline it with another color, or if you're shading with pencil and pencil, just make sure it is very evident where that darker part is. So for problem 2, both of these need to be solved for y. So the first thing we do on the top equation is move the x. 6 and x are not the same, so we rewrite -x plus 6, divide by a -3, and remember we have to flip that sign because we divided by a negative. For the second equation, I move the 2x. I simply rewrite, divide by -6. Again, because I divided by a negative, I have to flip my sign. So for this first one, we start up at 1. My slope is a +1/3, meaning I'm going up 1, right 3, up 1, right 3, up 1, right 3. This line will be dashed because there's no line under the inequality. And y is everything less than 1. Less than 1 is lower than 1, so we're going to shade the part of the line that goes lower than on the y-axis. For my second equation, I'm going to start at -2. My slope is still 1/3, so up 1, right 1, up 1, right 1, up 1, right 1. I'm sorry, up 1, right 3, up 1, right 3. This is also a dashed line because neither of these have filled in inequalities. I'm sorry, have lines under the inequalities. And y is greater than -2. A number greater than -2 would be 10. So again, if you're struggling to figure out where to shade, use 10 and -10 and figure out which of those directions do we need to go. So my solution set is going to be this rectangle in the middle where they overlap right in there. So that's going to be my solution set because that's where the black, in mine, the blue and the green cross. Problem 3, one of these lines has already been done for us. They moved the x by making it the opposite sign. They divided by a +6, and because we divide by a +6, our sign is going to stay the same direction. So we go up to a positive 4, up 1, right 2, up 1, right 2, up 1, right 2. This is going to be a dashed line because there's no line under the inequality. And y is less than 4. Less than 4 means lower than 4. Lower than 4 would be 3, 2, 1, 0. So you can use tens and negative tens. You could also use 0 and just always use 0 as is 0 bigger or smaller. For the second equation, we're going to have to solve, so we move the 2x to the other side. Remember that a negative 2x and a positive 30 are not like terms, so I simply rewrite them. And then from here, I'm going to divide by a negative 5. Now this one, because I divided by a negative 5, would flip my sign. 2 divided by 5 will stay 2 divided by 5 because you can't simplify that anymore. And then 30 divided by negative 5 is a negative 6. So to graph this line, we're going to go down to negative 6. My slope is 2/5, so up 2, right 5, up 2, right 5. This line is a solid line because there is a line under the inequality. And y is less than or equal to negative 6. Less than negative 6 would be negative 7, negative 8, negative 10. So I'm going lower than my line or underneath my line. So that would be this triangle in here where they overlap. So the blue and the red overlap down in that bottom triangle. On problem 4, we have 3 different lines that we need to draw, so we could do the special cases first. The first one, x is greater than or equal to negative 3, is a Vux, so we go over to negative 3 on the x. This one will be a solid line because there's a line under the inequality, so a solid vertical line. And then for my shading, x is greater than negative 3, 0 is greater than negative 3, having no money is greater than owing money. So I will shade to the right. For the second equation, y is less than 5 is a Hoy. We go up to where y equals 5. This is going to be a dashed line because there's no line under the inequality. Y is less than negative 5. Numbers less than negative 5 would include 0, so I shade down and include 0 in my shading. And then, like I said, this time we have a third line. So we have to solve for y first. We move the x, divide by the negative 3 because we divided by a negative. We flip our sign. And then we will go up to 3 on the y-axis to start. And then up 1, right 3, up 1, right 3, up 1, right 3. This will be a dashed line because there is no line under the inequality. So make sure you leave some spaces. And y is less than 3. Less than 3 is lower than 3, so we shade below the line. So my solution set is where all of them cross, where I have all 3 colors. So my solution set is what I'm highlighting right now, where I have the red, the blue, and the green consistently the whole time. Up here, I lose the red. Over here, I lose the green. So make sure you're really watching. Here, I lose the blue, so it's where all 3 of them overlap. So here, 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 to here, and all the way out to here. Now, they're asking us, without looking at the graph, how could you determine if an ordered pair is a solution? You could substitute both the x and y value into the inequality and solve. And if this statement is true, then it's true. And if it's false, then it's not a solution. So The first one's been done for us to determine whether this is a solution. We have the point 2, 1. So x is 2, y is 1. Excuse me. So we could take and plug in 2 for x and 1 for y and solve this. Negative 3 times 2 is negative 6. 2 times 1 is 2. Negative 6 plus 2 is negative 2. Negative 4 is greater than negative 4 would be false, because negative 4 is not greater than negative false. Negative 4 is not greater than negative 4. They are the same. So this would be false. And we have right here, if one or more inequality is false, then the point is not a solution. So without even testing this, we wouldn't have to see, but if we double check, 3 is not greater than 3. Both of these are false, so it would not be a solution. So for the next one, x is negative 3, y is negative 10. And again, we don't have to solve these for y, we're just plugging in. So this has already been started for us. Let's finish it off. In our calculator, we can type negative 3 minus negative 10. And we get 7. Is 7 less than or equal to 7? Yes, so that is true. The difference here is that equal to sign. This one is 7 is equal to 7, so that would be true. I can also plug this one into the calculator exactly like I see it. 3 times negative 3 minus negative 10 is 1. Is 1 greater than negative 19? Well, if I have $1, that's better than owing $19, so that would be true. So both are true. So the point, negative 3, negative 10, is a solution because both of them worked. Now, we have an example where both don't work and where both do work. There's also a time when you get one that works and one that does not work. All you're looking for is one false. If even one of them is false, then it is not a solution.